Bonjour everyone, my name is Thomas Vinadel, I'm an Unreal Authorized instructor, and today we're gonna explore one of the most interesting plugins of Unreal Engine 5, CommonUI. This tutorial is part of an advanced Unreal Learning series. So this is a tutorial that is designed for developers that already learn about the UMG and the C++. Throughout this session, we will focus on how to structure your HUD, manage efficiently your layers, and how to extend CommonUI so it's reusable on a large project. Let's dive right in. So let's launch the project in Debug Game Editor and launch it with the debug mode. For my use of Unreal Engine, I prefer use the IDE JetBrains Rider. So I'll go to Project Settings, Source Code, and I modify the source code editor to be Rider. Let's now open the plugin window so we can enable CommonUI on our project. Unreal will ask you to restart your editor, say yes and restart it. We can now create our own C++ class that inherits from the CommonUI plugin. So let's search for CommonActivatableWidget and select it so we can create our own child. If it is your first C++ class on this project, click on Private so we have both of the folders created on our source folder. Let's rename our class. For me, I will call it Tutorial Activatable Widget. We can now click on Create Class and wait for the project to compile. Let's organize this viewport a little bit. And now that we have our custom widget class, we will now create our custom stack class. So let's click on Tool, New C++ class, All Classes, and search for Common Activatable Stack. As we did for our widget, let's rename it. I'm going to call it Tutorial ActivatableWidgetStack. But if I open my output log, we will see that I have some errors. That's because we need to add CommonUI to our C++ config. So let's open our .build.cs, go to the dependency module names, and add two of them, UMG and CommonUI. Compile once again and it should work. Perfect. Now we can create our viewport that will inherit from our tutorial activatable widgets. Okay, so now that we have all our widgets created in C++, let's create a level so we can implement them and use them. Don't forget in the project settings to put our newly created level into startup default map and game default map, so like that it will launch automatically in our project and in our shipping build. Let's now create a new folder in which we're going to store our widget blueprint. Let's click on user interface, widget blueprint, and search for viewport. Let's give it a name. So for me, it's going to be w_viewport_main menu. This is basically the naming convention recommended by Epic Games. In this viewport, let's use an overlay, and not a canvas panel because it is too expensive. And this overlay will be used to store our widget stack. Let's put this one all the way left and rename it main_stack. Duplicate it so we can have our secondary stack. And duplicate once more for our popup stack. We can now create the widget that will be held by this stack. So let's create our new widget blueprint and give it a name. In fact, because we call the secondary stack, I'm gonna rename this as primary stack. So let's open this. Let's put an overlay to it and give it a border so we have something visible. Now we need to understand something about CommonUI. That thing is, everything is customizable. So if I want to add a button to my viewport, here I will see the main button, but this is not the one I want, because I want the button from the CommonUI plugin. And in this category, you can see that there's not any button of any sort. That's because we need to create it. So let's create a new folder to store it. Now let's create our button in C++. That will inherit from common button base. Just leave it like this for now. We'll come back later. So now, in my widget blueprint, we can see that I have my tutorial button right here. But we will not put it as it is. We're going to inherit them in blueprint so we can manipulate it a little bit more. So in this button, you can see that if I click in the root widget, I have some property that says style. This is what we call a style set in CommonUI. So let's create one so we have a style assigned to our button. So basically this is just an object that will tell which style my button will get from its state. For our use case, let's just use a single material, so we have a red button. So now we can assign our style set to our button. So first, let's put an overlay to this button so it will have something to show. Now get back on our root widget and assign its style set. And you can see our button is now red as we told in the bp_button style. So now just give it a text. My button is now ready to be put on my widget. We have a base to test, so let's compile that and put our widget on our stack. Click on it, and in the details panel, let's search for our root widget, so we can assign our W primary main menu. Now I want to be able to custom this button in each instance of it. Right now it's impossible. So that's why we created a C++ button. For this, I will just need to declare an ftext variable. And in this text, I will need to give it a color and a size. So let's create those both variables too. It compile and see where it goes. Now, if I go back to my widget, click on the root widget and search for text, you can see that my variable does not appear. That's because the C++ is hidden by default. So let's add a U property so we can show this variable to my blueprint. Edit anywhere so we have access to the details panel, and blueprint read write so we can modify it at runtime. And don't forget to duplicate it to each of my variables. Once again, hit compile and see where it goes. Nice, it worked. Let's now use the pre-construct of our widget so we can assign those variables to my text. For this, let's give a name to our text and make it as a variable so we can give access to it to our graph. So because of the edit anywhere, we have access to it in the detail panel, and because of our blueprint read write, I can now gather this text in blueprint. Let's do the same for our color. But as we can see, we have a problem here. The problem is the color type does not match with the one expected by this button text. It expects a slate color and I have a linear color. So the only way I have to do this is to make a slate color from this linear, but that's quite heavy. So that's why, after organize a little bit my code, we will modify our color type to be the right one for this text. So here let's just modify our linear color by a slate color. Hit compile. Then boom, an error. That's the same that we did for CommonUI. So let's go back to our CommonUI build.cs and add our slate to our dependency module. It's already here, so we just have to uncomment this line and hit compile again. Nice. We can now plug our color to our node. Now let's set our font size. As you can see, there's no direct node to set our font size. And that's because my font size is from a structure that is called font. So here we will need to set it like this. Split the struct so we can have access to our font size. But this method will need to override everything just to set our font size. That's not a great idea. So let's delete this and use another method. Because this is a structure, we can get it and do a set members to modify only the parameters that we want to. So here we have a better way to modify the font size. Give it some default value so we can see what it does. Great! So now my button is customized. But there's a problem. If I put it really big, you can see that nothing has changed except on the widget it's affected. So in my stack here, my size font will not move. And that's because of my set member. It doesn't work perfectly. So let's remove this and do this properly. My widget requests a font, so let's give it a font. Good. Let's assign this now. Give it some font so it's not bugged anymore. And now we can easily modify the font size. I'm just gonna give some default value to my button, so when I use it once again, it will have some default stuff that will show to me. So now I'm gonna give the right values to this button, which will be my btn_play. And I will need several buttons, so I'm just gonna wrap this one into a vertical box. And I will press Ctrl D to duplicate it. Rename them. And give them the right text. I can now reorganize them using the padding just to make this a little bit stylish. And I'm gonna do the same for my button. Now I'm gonna implement the secondary stack. Let's just duplicate the primary one. And rename it. Open this and just reorganize the buttons so we can give them settings name. I'm just gonna create two more buttons, one for the apply settings and one for a return. Wrap them into an horizontal box. And organize them. I am just gonna use a spacer so I can space them more equally. Great! This looks a little bit small though, so I'm just gonna use a size box to make it bigger. That's better. Now I'm gonna remove this from the root content widget because we want to spawn it from the settings button. So let's select our settings button, scroll down all the way down the details channel. So as you can see, I need to make my button as a variable so I can access the onClicked function. This is where we're gonna create our widget. But to test it, we will need to create our viewport on our level first. So let's quickly do this by creating a new folder named Game Manager, in which we're going to create our HUD, which will hold our viewport. This is where I recommend you to watch my 3C tutorial to understand how the HUD work in the gameplay workflow. We can create our viewport in Begin Play. And add it to the player screen. I'm gonna make this a variable so it's easier for me to retrieve my viewport. Now I will create a blueprint function library so I can gather my viewport more easily. I'm gonna name this function getViewport. And from here, I'm gonna access my HUD to get my viewport. Once again, if you don't understand how it works, I recommend you to watch my 3C tutorial. Now that is done, I can easily get my viewport from my widget. But as you can see, it has execution pin, so let's make this more readable by creating this function as a pure function. And to push the readability a little further, let's give it a compact node title. Yeah, that's better. So now I'm gonna make my stack as variables so I can gather them and use them. I get my secondary stack. And with CommonUI, we won't create a widget. We will push it on our stack. So let's call push widget, and we're gonna reference our widget. Now, if we hit play on our level, you will see that nothing happens. That's because our HUD is not referenced on our word setting. So let's create our own game mode. Remember that if you are prototyping a game, just use game mode and not game mode base. So now we can just reference our game mode and modify the HUD class to be our own HUD. If we hit play, boom, there's our main menu. And if I click on settings, I have my secondary menu that appears. I'm just gonna make some comfort code. So here I'm gonna put my game mode into UI only. And I'll also make the mouse cursor always visible on my menu. Everything's working fine, so now let's make our play game and quit button works. Once again, put our buttons as variables so we can use the onClicked functions. And for our play button, I will just open the level. So I'm going to select open level by object reference. and I'm just gonna open the open world. And for the quit button, I just have to call the quit game function. Let's try this. Okay, quit is working. Settings too. And if I play game, great! Now I'm gonna program the settings buttons. For more readability, I'm just gonna rename everything the right way and make the button as variables. So, what we need to understand about CommonUI is that it works with stack. So if I call deactivate on my return button, it will remove my current widget and put the last one in front of us. So here, because I pushed only one widget on my stack, when I remove it, there's no widget to show anymore. But let's see what happens when I push another widget into my secondary stack. I'm gonna create a new tutorial activatable widget, and I call it settings audio. Let's remove this. And I'm just gonna fill a vertical box with some generic settings stuff. I'm gonna change the background color so we have a little variation here. So now I'm gonna create buttons so I can exit this settings menu. Cool. Now I'm gonna call their onClicked functions, and I will deactivate my widget for the return button. Let's get back on our settings menu, select our BTN audio button, and on clicked, we're gonna push our new widget on the secondary stack. So now, if I click settings, I have my settings menu. I click on audio, I have my audio settings menu. And if I click to return, I get back to my settings menu. Widget transitions are configurable in my details panel, either if I want some vertical or horizontal transition instead of the fade. For example, let's put a vertical animation to it. Nice, it looks great. Okay, so now let's do the pop-up. I'm just gonna clear this a little bit. So what we have now is when I click my quit button, it quits the game. But I want a pop-up that asks me if I really want to quit the game. So let's create a new C++ class as a tutorial activatable widget. Give it a name. And we're gonna inherit it as a BP. Here I'm gonna give it an overlay, a border, and the background blur. Now let's fill it with some text and button that my pop-up should have. I'm gonna use a size box just to make sure that my pop-up is always the same size. And I'm gonna do the same for my buttons. Okay, now it looks great. I have a prompt and two buttons, one OK and one return. Now I just have to integrate this in my quit button. So let's click on it, search for the onClick function. There. Let's push our widget on our pop-up stack. Now what I want is this widget to execute the quit game. But as we did a generic popup, we can go in here and execute the onQuit function. If I do this, my generic popup will turn as a quit popup. I could inherit a widget from this so I can create my own, but let's do something more fancy. Here, what I will do is to ask my widget to generate an event. That's what we call a delegate. For this, we will need a little C++. So here, just after the includes, let's declare our delegate. As you can see, there's a lot of them, but we're gonna use the delegate one param so we can return the widget that asks this button to be clicked. So I'm gonna call my delegate f on popup OK, and it will return a class uTutorial popup widget. I'm gonna give a name to the return value like popup widget. And there, my delegate is declared. So now I will need to reference this delegate into my class so I can use it. Now let's create a function that will make our delegate visible in Blueprint. For that, I'm going to create a public category. I'd just like to organize my code by creating sections for variables and functions. Here, our function will return void, and it's just going to be an initialized popup. For the input, I will just ask for my delegate and a boolean that will ask if I want to close my popup on OK or not. Let's create our definition. And in here, I'm just gonna call the event created by the delegate and ask if I want to close my popup or not. For that, I will need a handle for my event, and I'm gonna store the boolean too. Let's just store the information that are given by the initialized popup. Okay, so now everything's ready for my call in BP. But to be able to call it from my push widget, I will need to make my initialized popup visible in Blueprint. This is where the uFunction macro is used. This will basically allow me to make it blueprint callable and I'm just gonna give it a category. So with my right click, I can easily gather it. I can push things a little further by creating a meta param just to make my auto close and OK as an advanced display. So now everything should work. Let's hit compile and see what it does. Okay, so now if I look for my initialize popup from my push widget, I'm able to ask my function, and we can see my delegate and my boolean as an advanced display. So let's create a custom out of this delegate. This is the event that will hold my quit game. Let's give it a try. So if I hit play and I hit quit, my popup is here. But if I click OK, nothing happens. And that's normal because we define our delegate, but no function is executed here. And for that, we will need a few things. First, we will need the button that is clicked, so I can gather the onClicked function on it and connect it to my onPopup OK. And this will be done on the initialize of my widget. So let's create a protected category so I can inherit from the, not this one, the initiation of my widget, initialized. Okay, so here what I will need to do is take my button and says when I click on it, I want to execute my own popup, but I have no reference of my button. And this is because my button is not created in C++. It's created on my widget blueprint. And this is where we're gonna use the bind widgets. So for this, to gather my button reference, I will just create in the variables a protected category so I can store my button. This will just be an object pointer of a tutorial button base. Let's give it the same name as we did in the blueprint and make it null pointer by default. Let's just give it a U property so my button is not collected by the garbage collector. So now that I have a reference of my button, I can first check if the reference is valid, and then assign the onClick button to the created event of my delegate. Let's find the onClicked function, and then bind it with the addUObject function. But as you can see, I will need a function to bind to my onClicked function. So let's create it so I can reference this function in my addUObject. Here, I'm gonna create a private function that return void, and I'm gonna call it onOkClicked. And this signature is what I'm gonna use as a reference to bind my function. And now this is the easiest part. I'm just gonna call my onPopup OK delegate, execute it. As I have chosen a delegate one param I need to return something. Here, my popup widget. So myself, this. And I'm gonna check if I need to close my widget or not. If this is the case, just deactivate widget. Now everything should work. We have our initialized popup here that will register our delegate and our boolean. On initialize of my widget, I will get the onClicked function so I can bind my custom onClicked function to it. And on this custom function, I'm going to execute the event created by my delegate and deactivate my widget if I ask to. Let's hit compile so we see what it does. If this occurred, that's nothing, that's just a debug point from the live coding. So it has compiled. Let's check our BP, if everything's okay. If your variable is typed as live coding, do not panic, that's normal. This is because we have modified a .h and we have not recompiled the whole project, so that's just a hot reload. Oh, this one cries. Just recreate this. So if you try, let's click on quit, click on OK, and nothing happens. And this is because in our C++, we referenced a button, but nothing is bind into it. This is where we're going to use the bind widget meta u property. Remember when I told you to use the name that we're going to use in widget blueprint? This is because of our bindings. As you can see now, my btn OK is referenced as a binded widget. And if there is no tutorial button base called btn OK, the object will not be binded. That's our case. So let's rename this to be btn underscore OK. And now my widget is considered binded. So now, if I play, I click on quit, I click on OK. Nice. Everything worked as expected. My parent hold the logic for my popup widget. So now I have a generic popup that will be used for anything. We just need to customize the prompt text so it can ask the right question. So in my initialize popup function, I'm just gonna add a parameter that is a ftext. And as we did for our button, I will need to bind my text widget. Now that it is binded, I'm gonna check if my value is valid and just set its text. And let's compile to see where it goes. Okay, so it compiled, everything is binded. I have my delegate connected to my initialized popup. And if I refresh node, I have my prompt text that I can promote to variable. Let's give it a value. Refresh this one. And it works. We just need to deactivate the widget on the return button. But that's easy. So, when I hit my quit button, I can return, and if I click OK, boom, it closes the game. Everything works as intended, so now I can use this method to create every pop-up that I need in my game and program its logic to the parent that calls it. And this concludes our tutorial. Alright, let's wrap this up. In this tutorial, we've gone from the basics of CommonUI all the way to implementing a full professional UI flow. We have seen how to organize our HUD, how to manage our layers, how to implement our own override of CommonUI, and even how to create a generic pop-up that holds any logic that you want. These are the foundation you need to scale toward a fully functional UI architecture. Feel free to use the result of this tutorial as the backbone of your future projects. Thanks a lot for watching. Au revoir.